Okay, let's do another discussion. Well, here is this final exam review. Notice some things that we see. You got to show all your work, explain your steps, and make your work clear and easy to read. So when we have this, you got to think, what are they trying to see if I know? They're trying to see if you know your exponent rules. So a big root is equal to stuff to the 1/2. A cubed root is equal to stuff to the 1/3. If you raise to a power and then raise again, you multiply the exponents. So 30 times 1/3. So 30 times 1/3 is just 10. But then if you have a fraction to but then if you have like bases, you just subtract the exponents. So that's where 2 comes from. Then raise to a power, you raise again, you just get 10, because it's 10 to the 1. Similarly here, if you have something to the -1, that's the same as 1 over that thing. Well, then I need to get common denominators when you add or subtract only with fractions. So if I hit this with 5 over 5, I get 10/15. If I hit this with 3 over 3, I get 13/15. So that would give me 7/15. So it's this times this, but then when you divide by this fraction, that's the same as multiplying by the reciprocal. And notice that 1 over 15 squared is the same as 1 squared over 15 squared, and that's why I wrote it like this. So then these 15s cancel out, and just leave you with a 15 here, a 7 here, and a 5. But then if I cancel out a 5 out of those, I'm just left with a 3, so I get 21. This is not the only way to do this problem. You can notice that this is the difference of 2 squares, and works out quite nicely. But another way to do it is just expand this to get that. Expand this carefully inside of parentheses. So you have to make sure that all of this is in parentheses when you expand it. So this negative distributes, and you'll just end up getting 4xy over 4xy, which is 1. Okay. Here, they want you to solve for x. The big thing they're wanting to see if you remember here, and I don't want to make it super scary red. If you have a plus b over c, that's equal to a over c plus b over c. That was a note, right? So common denominators mean you add together over the common denominator, or you can take a fraction and break it up. So what we're going to do is we're going to take this fraction and break it up over the 8 to the 20. When I do, stuff happens nicely. These cancel out, give me x. These cancel out, give me a. How would I have known to do that? Well, again, you know at some point you're wanting to solve for x, so you know you need to make it look different. And I remember that one way to make it look different is like so. But then, do you see the a's cancel out? You subtract 10, and you just get x is equal to 1. Textbook, this test author thinks they're cute. How do you solve the absolute value of stuff is equal to 1? Well, the only way that your size can be 1 is if you were -1 or you were 1, because that's what absolute value is. It's just size. So you get -1 or -9. Here, notice it says factor. There is no solve because it's not equal to 0. So you must keep this equal to what it is equal to the whole time. Factor out of 5 and get this, and then factor that into 2 binomials. So that is your answer. Okay. Domain, you have to know that you're looking at the square root of a negative or stuff over 0. So if I look at square root of a negative for this one, I end up getting the radicand is greater than or equal to 0. So we get x is less than or equal to 1. So it's all this stuff. Stuff over 0, I do have stuff in the bottom, so I set the denominator equal to 0 and get plus or minus 2. That means you do not want to be those values, so you can be anything but. So now I look at the overlap. I need to make that happy and that happy. When I make those conditions happy, this is what I get. All right, here we're graphing an absolute value function, moving that thing around. Notice we want to work from the inside out. So this thing moves right 2 and up 2. So I start off with my original and I move it right 2. And then I move it up 2. Notice I'm letting the reader know that I understand that this point moved from 0, 0 to 2, 0 to 2, 2. Find the slope-intercept form of the line. Well, I would first write down y minus y1 is equal to mx minus x1. That point slope form is the one we use most. They want to be parallel, so that means same slope. And then they say parallel, but they want to go through this point, so that means that is your x1, y1. So my x1, y1 is 0, 2, 0, 2, and I need a slope to be the same as the slope of this line. When I solve for y, I get y is equal to 2x minus 170, so slope is 2. And that's why this goes here. For what value the vertex does this thing, for what value of d is the vertex of the parabola on the line 2? Well, I know the x-coordinate of the vertex is always negative b over 2a. If you don't have that memorized, memorize it. So this means that my a is 1 and my b is 2d in this case, where d is some constant. So I do negative b over 2a, and I get that x must be equal to negative d. But if I want to lie on the line x equal to 2, then that means that negative d must be equal to an x of 2. So 2 is negative d, and so d is negative 2. Find the equation of a circle. Again, have that sucker memorized. Memorize the equation of a circle. And they want it to be centered here. That means that's your HK. Blam, blam, I'm almost done. But then going through the point just means I need this radius. So if I'm going through this point and that's my center, then this distance is my radius. So we use the distance equation, which is wonderful to have memorized. And I get r is equal to 5. So that means r squared is 25. All right, let me see. 1, 2, 3. Got 3 pages left. Almost done. Let's push. So solve this system. We know that when we're solving systems, for us, we either do elimination or substitution. Those are the only tools that we have. There are a lot of other cool ones later that you can learn in linear algebra, which are just kind of versions of it. Really pretty. So we're going to solve this one for y. When I do, I get this. I label them 1 and 2. I plug into equation 1. So this equation becomes this equation. So x is equal to half. I plug it back into equation 2 and get this. Notice how anybody that picks this up would be able to follow the reasoning. That's what yours will look like. So when I come to here, I label these again. I notice that I want to get these suckers to cancel out, so I'm going to multiply the top one by negative 2 and get this. So now when I add them, I get x is equal to 2. I plug that back into 1. So if that's equation 1, I plug in 2, I get this. I get y is equal to 1/4. Here you go. I have an exponential equation that I'm trying to solve. I want to get this down out of the exponent, so I know that I take the natural log of both sides. That means this can come down here, and this can come down here. How important are these parentheses? These parentheses are so, so important. These parentheses must be here. Or you're only multiplying this by only 6, not by both. Only multiplying this by 3, not by both. Very, very important parentheses. We end up getting that x is equal to that. Very similar to homework. Here, they're wanting to see if you know your log rules. So, again, they want me to simplify. Maybe I've never seen one like this before. So I just say, well, what could you do to make it look different? I know that the log of a product is the sum of 2 logs. Then the world gives me feedback, and I'm like, oh, I'm on the right course because I can pull down a 4 and a 2x. But then I must know that the natural log of e is 1. You've just got to know that. So that's 1 and that's 1. So if the natural log of e is 1, then this is 1 and this is 1. So I get 2x plus 4 on the top it simplifies to 2. How pretty. All right, so then they want to know, I've got 10 feet of fencing available, and it's going to be a rectangle. So if I'm going to have a rectangle, sorry, I put the wrong emphasis on the wrong syllable. If I've got a rectangle, I've got a length and a width, I know that for fencing, I'm going to have 2 L's plus 2 W's going to equal all my fencing. So that's where this comes from. If I solve it for L, I now know that L is equal to this. So they want to talk about area. I want to know for what widths will the area be greater than or equal to 6 feet. So at least means greater than or equal to. So we want the area to be greater than or equal to 6, but area is equal to length times width. So if I plug this into here, I end up getting this, which is this. So if you want area greater than or equal to 6, then this must be greater than or equal to 6. So I now have a polynomial inequality, but I can factor that sucker, and instead of thinking about where this is less than or equal to 0, I can think about where is this parabola less than or equal to 0 by finding its zeros. So we know that this is going to be a parabola that opens up, so it's going to look like this. I'm wanting to know where is this. Oh crap, I got this wrong. Oh crap, let me fix that really quick. I wasn't thinking. Yay, it makes it much easier than what I was thinking. This is what I get for trying to do this late at night. Okay, let me go here. So here, I'll just fix it this way. So if all of this is my parabola, and I'm just wanting to know where is it, where's that thing, parabola less than or equal to 0? Do you agree that it's less than or equal to 0 between 2 and 3? So it just means all the values between 2 and 3. Yay, that's what's going to make it happen. Cool. So as long as your width is between 2 and 3 and not too big, you're going to have a big enough area. That's pretty amazing. Okay, 600 people attended a movie. You got kids and adults. We've done this one before. A is adult tickets. C is the number of children tickets. What we know is that we got to have 600 tickets. This is the number of tickets equation. But then we know that 9 times A plus 6 times C is 480. That's the money made equation. So now I've got 2 equations and 2 unknowns. Dude, you just solve them by substitution or elimination. I'm going to solve 1 for A to get this, then plug it into 2 to get this. So we get C is equal to 200, and I answer the stupid question. So 200 children must have attended. Let me make sure I answer this stupid question. For what widths? So up here, I guess I should have said, so widths between 2 and 3 is what we wanted for that one up here. So just making sure to answer the stupid question. Down here at the bottom on our penultimate page, say the city has, we got a population and time in years, and it's increasing continuously at a constant annual rate. So that means that we are in an exponential growth sort of situation. Okay, so they say the rate is 5%. That's where this comes from. Initial amount of 100,000. And they say if we start off in 1970, they want to know what's going to go on in 2025. Well, that's going to be 55 years. So as per usual, we take time equals 0 to be whatever the starting year is. So that means 2025 is time equal to 55 years after we started. So we have this many people in 2025. Notice the beautiful way this test creator set it out for you. They said, do not calculate the exponential function in your answer. So this is allowed to be your answer. Cool. So what do we see? So 8% compounded continuously. It's going to be PERT. So they want to know how much do you need to do if we are doing 8%. And it's going to be 36 years. I went ahead and marked off this date, because it turns out that they probably gave this test on December 13th. Does it say it on the front? Probably does, because again, this textbook author thinks they're cute, or sorry, test author. So we'll just say, don't worry about it. It's probably, who cares? We just want the number of years. It's 36 years from the start, right? So for $1 million, how much do we need to start with? We need to start with this much invested today to get what we wanted. Because again, they were pretty thoughtful and said, look, do not evaluate the exponential function in your answer. So that means that this is just your answer. And we did this last one in class. If you have T is the price after tax and P is the original price, if you multiply by 1.2, that's a 20% tax, and you get the price was $20,000 before taxes. See you soon.